Good evening, everybody. It's my pleasure to introduce Dr. Atilla Batmaz, from his research assistant at Ege University in Izmir, the Archaeology Department of Archaeology, Proto-History and Near Eastern Archaeology. Attila graduated in 1999 from Ege University and did his master's as well as his PhD there as well. But in between, he went to Munich with an Erasmus scholarship. And in 2014, he spent time, I think, whole year?
6 months.
6 months in Melbourne University as a postdoctoral fellow with a scholarship from JÖK. He's excavating in Ayanis Castle in Van, but also in Ulucak, near Izmir, where he's working at a Neolithic site. His specialization, however, is especially on Urartu, where he's working on material culture, especially on metallic objects, but also, as we will hear later, on ceramics. He was involved in a large ethno-archaeological project concentrating on the comparisons between Ayanis Castle and the present-day villages around in the area. As well as in 2012, he was part of a project concentrating on the mapping and the restoration of the damage that the large Van earthquake caused to Ayanis Castle. And he has many publications on all these different topics. Today we are going to hear on a Van-related topic. Attila Bey will first give an özet in Turkish, and then afterwards he will continue in English. He's going to, as you can see, he's going to talk on Urartian pottery, and for several of us, of the BIA, this is a special occasion because we were in Van last year and we saw Attila Bey in action there, so we are really curious to hear what he has to say about it. And so I would like you to invite to report.
Thanks very much for this very kind introduction. I'm very pleased to be invited to this conference series. I'm very excited to give a talk for British Institute at Ankara. Öncelikle bu tanımın dediği gibi bir Türkçe özet vermek istiyorum. Ve bu akşam sizlere bir deneysel arkeoloji ama birazcık da etnoarkeoloji ve etnoloji üzerine konuşma yapmak istiyorum. Bu konuşmanın özetini şöyle ifade edebiliriz. Aslına bakarsanız Urartu seramiği üretme konusunda farklı zamanlarda farklı çalışmalar yapılmıştır. İran'da yapılmıştır, Almanya'da denemeler yapılmıştır. Ancak üzerine de çok yazı yazılmıştır. Ancak bunların hiçbiri yerel killerle, yerel seramik ustalarıyla yapılmadı bu zamana kadar. Bizim de amacımız bunu Urartu seramiği olduğuna göre, Urartu'nun ana yurdu Van olduğuna göre, Van'ın hala seramik üzerine çalışan yerel seramik ustalarıyla bir araya gelip yerel killerle geleneksel usulde bir çalışma yapmak istedik ki bu çalışmanın tarihi de 2013 yılına dayanıyor. Van'ın Bardakçı köyünde şu anda son kalan seramik ustası, onun dışında seramik yapan hiç kimse yok. Bir gün bizi ziyarete geldi Ayanis Kalesi'nde ve bu seramiği yapabileceğini söyledi. Oysa ki sonradan anladım ki aslında Urartu'nun bu kırmızı seramiğiyle ilgili hiçbir bilgisi yoktu. O sene ben onun köyüne gittim ve beni birkaç gün misafir etti ve ondan sonraki sene ne yapabileceğimizi oturduk, konuştuk. Yerel killeri çok iyi bildiği için, fırınlamanın o killer üzerinde nasıl yapılması gerektiğini çok iyi bildiği için, plastiklik düzeylerinin nasıl olduğunu iyi bildiği için bize bir anlamda o killeri tanıtmada yardımcı oldu ve biz de öncelikle Urartu formlarını üretmeye çalıştık. Ki bu formlar daha çok tek kuplu yonca ağızlı, ufak boyutlu, yuvarlak gövdeli testiler, açık kaseler şeklindeydi veya gobletler şeklindeydi. Öncelikle ona formu gösterdik ve çok güzel bir şekilde orijinal yerel killerden üretmeye başladık. Ancak ikinci nokta, asıl bizi uğraştıran nokta üzerindeki kırmızı astarıydı. Bu zamana kadar hep terminolojik olarak da kırmızı astarlı veya kırmızı açkılı diyelim, Urartu seramiği olarak isimlendirilir. Bunu yapmak o kadar da basit olmadığını yaptığımız çalışmalar sonrasında anladık. Temel olarak deneysel çalışmamızı doğrudan seramik kap üzerine yapmadık. Onun yerine test plakaları, deneme plakaları yaptık. Farklı denemeleri, farklı killer üzerindeki denemeleri, onların astar denemelerini üzerlerine uyguladık. Daha sonrasında fırına verdik ve çıkan sonuçları değerlendirdik. Nerede hatamız var, neyi tekrardan düzenlememiz lazım gibi böyle bir çalışma yaptık 2 senedir de. Hala tam istediğimiz noktaya geldiğimizi söyleyemem. Çünkü bu çalışma halihazırda devam eden bir proje. Dolayısıyla şu anda ilk pişirim denemelerimizi yaptık ama hala şu anda Urartu'nun istediğimiz kırmızı, parlak, astarlı seramik tarzına ulaşmamız için birazcık daha yolun olduğunu görüyoruz şu anda. Şimdi isterseniz İngilizce olarak devam edelim. Sesim güzel geliyor mu yoksa? Tamam. To be honest, as an archaeologist, I don't have any particular interest or proficiency in ceramic studies. Discounting my field experience in Neolithic sites in Izmir over the years, I have worked in an Urartian fortress called Ayanis since 1996, which is located on the eastern shore of Lake Van. Thus, one way or the other, I had to learn more about ceramics, one of the most important material culture components of archaeology. On the other hand, this is my first experience of being involved in an archaeological project at the experimental level. Thus, I hope that you will excuse any shortcomings and errors in this talk, which aims to present our attempts to reproduce an ancient ceramic type using the traditional methods practiced in the village of Bardakçı in Van in eastern Turkey. In this respect, I would greatly appreciate your criticism and your guidance. One of my main goals in my early career was to expand on my knowledge of Urartian kingdom, which reigned from between the 9th century and the 6th century BCE. Its capital city, Tushpa, was located in Van. A modern Van city is brimming with innumerable works and monuments of the kingdom. One of the most important surviving legacies of the Urartian kingdom, which ruled eastern Anatolia, Armenia and northwestern Iran for more than 2 centuries, is Urartian red Polish pottery, or Urartian burnished Urartian ware, or palace ware, or Toprakale ware, which has unique characteristics. Apart from the red color that gives this pottery its name, the pottery's final appearance is achieved using a delicate, intense surface treatment process. This pottery is also called BIAA ware by some archaeologists, since the Urartians called themselves BIAAlians. The glossy red pottery is representative of Urartian culture, owing to its bright red slip, and is found in almost all Urartian fortresses. And it is thought that the production was arduous and required a high level of expertise and technical skill. It is understood that some red Polish vessels were imitations of metallic vessels, especially of single-handle trefoil jugs. This might be explained from the long history of mining in Urartian culture and its dominant role in it. The fact that it was found in small numbers in fortresses that is arduous to make and is highly aesthetically pleasing leads us to believe that this ware may have been used by the ruling elite, and so it is also sometimes called palace ware. The highest quality examples of this type of pottery were produced in the basin of Lake Van, the center of the kingdom, and marked drop in quality is observed from the further one goes from it. Red Polish pottery is clay with brown, red, gray, and grayish-black colors, and usually fine sand-tempered and fine thin paste without temper. There are also medium paste quality examples with coarse sand inclusions, although these are not common. It is accepted that the most distinctive characteristic from the point of production technology is a thick slip application and surface treatment, which differs from the pottery technology of the region in previous periods. Analysis has shown that its red color comes from the red iron compounds in the slip. The slip is sintered and the clays are derived from lithic clays, and thus it is very fine grained. I believe that it may take on a glossy, non-porous, shiny look being compacted after firing. The most common forms of Urartian redware are service vessels such as trefoil jugs and related jugs, pedestal vessels, bowls and plates. These pots are aesthetically pleasing, not permeable when using for liquids, and light. They are serving pots, not cooking pots, and are subject to the different processing, which may enable them to be produced with less tempering. When compared to other ware groups, it's understood they are produced according to certain rules related to physical appearance as surface treatment, firing techniques, and typological properties. This wheel-made pottery was rarely decorated and was probably produced in large central workshops. The earliest samples known are dated to 8th century BC. It is suggested that this Urartian ware disappeared after the collapse of the kingdom. Yeah, these are from Ionis excavation. The excavations at Ionis fortress, which was founded by King Rusa, son of Argishti, in 7th century BCE, has yielded thousands of red Polish pottery during its 25-year excavation. Perhaps this abundance shaped our approach to the study of the site and reduced our appreciation of the ceramic materials. While appreciating the beauty of the fragments found, I personally believe that the red Polish ceramics that identifies the Urartu were quite uniform. As a general methodology of ceramic studies, the characteristics of the pottery such as form, color, paste, inclusions, ornaments, if any, analogy, typology, and the area and proportions in which it is found are usually evaluated. Of course, these characteristics provide important information about the culture in which it was created. On the other hand, many questions about the technique and stages of production of a specific type of ceramic or any material cultural element are hard to answer. Of course, this is not among the primary tasks of an archaeologist. Describing the physical characteristics of the ceramic and positioning it within its society is generally considered enough. The idea of producing ancient pottery with the raw materials and methods of its period is both appealing and risky. The process is long, and it requires cooperation between different disciplines and local potters, and the product that is obtained is expected to be of the desired quality and physically successful. In short, writing down the physical, chemical, and artistic characteristics of pottery is easy, but managing to produce it is hard. When we began thinking of producing red Polish Urartian ceramics with a local potter in Bardakçı, we appreciated that the work was going on to be harder and more complicated than we initially thought. While considering the Urartian process of ceramic production for these vessels, we noticed the fine details, skills, abilities, and knowledge present, as well as the difficulties the potters would have encountered. Its production would have required collective and organized work. So what is the beginning of the story? First, I would like to give you some brief information about how we decided to attempt to build a project focusing on the reproduction of the Urartian ceramics. In the summer of 2013, I met a local potter from the village of Bardakçı named Osman Eşme. When he came to the Ayanis excavation when we were in the field, I realized that he was closely engaged with local clays and had vast knowledge of pottery making. At the end of the excavation season, I decided to go to Bardakçı to do exploratory observation. In his small workshop, which was converted from a barn, he was treating local clays, firing pottery in a mud brick kind of beehive kiln, and mostly using a kick wheel. He and his family were very nice and kind to me, and they hosted me for 5 days in their home. I felt satisfied that we could work together. I learned that he is the last potter to still make local pottery. There were others until 1976, although some of the old potters are still alive. In terms of the historical background of the village, here's Tuşba, the capital of Van. Here's Ayanis fortress. Here's right in the middle, Bardakçı village. The pottery history of the village is really quite interesting. In fact, Bardakçı village of Van is no different from many other Eastern Anatolian villages with its dusty roads and smell of fresh manure. However, its traditional mud brick houses and subsistence strategies have changed considerably when compared to the past. Bardakçı is a settlement on the eastern edge of Lake Van, 12 kilometers from the city. The village next to Yüzyıl University was settled by Armenians prior to Turkey's Republican period. The Armenians, who at the time earned their living by making pottery, settled in the area because of its abundant water sources and the suitability of the soil for making pottery. During Ottoman times, traditional Bardakçı pottery was made and sold in the village, and there were around 15 workshops in the village at that time. The same workshops were used by Osman's grandfather and father. Turks settling in the area during the Republic period of Turkey continued producing pottery. Walking through the village, one can see the green soil, ceramic fragments, wood ash, and kiln bricks. It is not surprising that the name of the village is Bardakçı, because in rural Anatolia, the word Bardakçı means potter. In the 1960s, there were 45-50 houses and about 12 workshops. 2 to 4 potters work in each workshop. Some of the villagers earned a living by collecting firewood. Another group bought the pottery made in the village in bulk to sell in Van. Each workshop, it was essential for there to be at least one potter apprentice, known as a şagirt, and one çamurcu, that means mud maker, to work. If only a potter and şagirt worked in one workshop, and the şagirt also did the mud making, then income was split in two. Half of the income was always the potters. However, many people were left. They split the rest evenly. To become a potter required working continuously for at least 4 years alongside a potter. After approximately 5 years, apprentices would become professional or master potter. A master potter is capable of making a charn that holds 5 tenekes. Tenekes, a type of metal container. 5 tenekes of water, or to make a jar at scales of 3 or 5. Ceramics began to disappear from the market since plastic and aluminium containers were lighter, cheaper and less fragile. The last pottery workshop in the village closed in 1976 and no working kilns remained. One of the last potter of the time, Osman's father, Potter Şaban Usta, stopped making pottery and started other jobs in 1976 when the plastic industry began to take the place of pottery. Osman's story began here since he was born in 1977. He never saw any working potters in Bardakçı. The older sister of Osman, Gülhan Eşme, went as a bride to the village of Ayanis at the beginning of the 1990s. Osman, then 13 years old, frequently visited Ayanis to help his brother-in-law with mowing, haymaking, gardening jobs, and harvesting fruit. The archaeological studies at Ayanis fortress has only been in progress for a few years then. It was not long before Osman noticed the nearby fortress and the Urartian ceramics inside. Many types of pottery fragments in the fortress, including red Polish pottery, became very important to Osman. By the time his father had given up making pottery, as had the other potters in the village. For this reason, it was not easy to carry clay, build a kiln, and find men to work. Even though Osman's enthusiasm for pottery came late, he managed to convince his father to help him. That winter, in the village, his father explained in fine detail and over many hours just how ceramics were made. With words and gestures, he showed his son how to use his hands to make the pottery. Soon after Osman's father passed away, other old potters helped him to complete his training. Normally, it would take 4 or 5 years to become a potter, even when working as an apprentice with a professional. However, Osman learned in 6 or 7 years by trial and error with the paste. He tried to replicate the forms and specialties of old ceramic pieces he found in the village. When I first met Osman Usta, I saw that he was willing to make an Urartian pots, although he had no idea about Urartian red Polish pottery. He was making pottery with local clays, plain, untreated pieces with various familiar and unfamiliar forms, using no slip, but bearing simple incised decorations. However, the whole process of making traditional pots that begins from the obtaining clay from the local sources and ends with the firing process was extremely interesting. Most of the time he wasn't use any modern tool during the treatment of the mud. At the beginning I had only one goal in my mind, reproducing Urartian pottery. When I heard the history of the village and saw its unique traditional ceramic works, I decided to build a project covering not only experimental archaeology, but also an ethnological and ethno-archaeological study. The reason for this is that there is an information gap about traditional ceramic production and technology. There was no published detailed research on traditional pottery making of bardakçı that had been done before. This unlucky situation turned into a fortunate one for me, since such a study would help us to obtain solid information about Urartian ceramic technology. Therefore, the method we used to describe the stages of our experimental archaeological studies will be based on the production traditions of the village. Now, turn to the Urartian wares. There are subtypes of this pottery, and these are first quality, toprak kalaware, for example, second and third quality. The BIAA ware or palace ware, mentioned earlier, is very fine first quality, while second and third quality wares is called fake or pseudo-Urartian red polish ware. They are thicker than the first one, red or brown, and not very shiny. I've chosen the first subtype, Urartian red polish ware, for the research. The outside and inside of open vessels of this pottery type is smooth, red and shiny. It is not always, but most often well fired, and its paste is fine or very fine grained thin paste. Experimental work and implementation. The experiments were realized basically in 5 stages: raw material procurement, paste preparation, building process and scraping or preparing the test pieces, slip experiments and application, and firing. The potters working in royal workshops in the Van region must have used one or several clay deposits for raw material procurement, since not every clay deposit is suitable for making ceramics. After selecting the deposits, the soil to be used would have been carried to the workshops. The workshops would not have been located far from the sources of raw material. Procuring quality raw material is very important for successful production. We learned that each potter had their own site for raw material procurement, and a potter could not take clay from another potter's site while that potter was still active. It is conceivable to imagine a similar situation in Urartu. The clay deposits used by royal workshops must have been selected and protected by the state. 2 types of clay are used in bardakçı. The first is a green clay called kahcin, which is procured from a deposit called torpalık near the village. This clay is used for most of the traditional produced pots in bardakçı. The other type is a red clay called thunder soil from Zebe, which is 1 kilometer away from the village. This soil is mostly mixed with green clay to produce cookware such as güveç. We use both clays to biscuify the test pieces, but we prefer the red clay for slip due to the red color. Here are the basic characteristics of the clays. Green clay. The forms made in the village with this clay type are water jugs, cheese storage jars, grains, legume and dry food storage pots, pots for wine, oil, vinegar, yogurt, yeast, pickles, cacık pots, kuru tezen. This is the pot for a type of dry cheese. bowls, cups, and flower pots. Its ideal baking temperature is 900 to 1000 Celsius degree. It becomes white at 1050 and it becomes brick reddish at 850 degree. Red clay. The forms made in the village with this clay type include pots, wine and vinegar pitchers, tanders, gueches and bowls. It reaches the ideal red color at 600-700 Celsius degree. It turns yellow at 800. It starts to deform at 900 Celsius degree. The paste preparation. We have no information on how paste was prepared in Urartu. Therefore, the entire process was done using Bardakçı's traditional methods in these steps. First of all, soil is taken from the clay deposits and spread on the ground. It is dried in the sun and the cloths are crushed. It is sifted. The sifted clay is mixed with water in a pit, or nowadays Osmanlıs are using a plastic container, as you can see in the slide, and turned into mud, wet clay. The rest is mixed with the wet clay to reach the desired consistency. This is called palur. The clay is heaped up and trayed out when it reaches the right consistency. This spreads it out on the ground until it is 4 to 5 centimeters thick. It is cut into 30 by 30 centimeters squares. The pieces in the middle of cut clay are taken to another place. The rest are arranged in a circle. Their consistency is checked. If they are too soft, that means wet, some sifted clay called poshi is sprinkled on them. If they are too hard, that means dry, fine sifted sand is sprinkled on them to protect their consistency and keep them from hardening. 2 squares are placed in the middle, then one of the squares taken from the middle is put on them, and this is repeated until all squares are used. Then all clay is mixed very well. It is traded out again after this step, and then the entire process is repeated 2 more times. After all these steps, it is cut in pieces to be used as a blocks. If the blocks are too dry, water is sprinkled on them using a broom. The correct consistency is very important. The potter cannot work if the clay does not have the correct consistency. The pottery will be of poor quality and too thick. It may explode when fired. The person who performs all these steps is called a çamurcu mud maker. The paste is covered and left to rest. In the next step, the paste is taken to be processed by an apprentice called a şagird, who puts the paste into its final form for the potter. The şagird separates the paste with his palm, as you can see here. As if grinding it in slice by hand. In other words, he sifts it again. The aim of this is to eliminate air and all other foreign matter from the paste. Finally, he divides the paste into pieces called bendem. The potter will use these pieces to produce pottery. When it comes to forming and scraping, in this stage, Urartu's such basic forms as trefoil jugs, open bowls, and goblets are produced and processed from the paste prepared red clay. We have evidence from Ayanis fortress on what an Urartian wheel was like. It is, in fact, 2 seal imprints on a reddish-brown body shirt. On the imprint, a potter, probably sitting on a 2 footstool, a potter's wheel and a pot being produced is visible. You can see this is double twins. Potter's wheel and the pots. The potter spins the wheel with one foot and stretching out his hands shapes the pot on the potter's wheel. It is widely accepted that some geometrical and floral motifs or signs symbolize the workshops in which the pots were produced. Along with providing existence of pottery ateliers in Urartu, this particular one demonstrates the type of the wheel. This is very important for our research, since there are 7 different types of wheel in rural Anatolia. The imprint depicted the exact copy of a wheel used in Bardakçı, a kick wheel with a disc spoon on a long spindle. The main problem in the stage scraping is the suitability of the clay for producing the thin-walled vessels of the time. It is especially hard to produce the Urartian vessels such as pitchers with a round body, a thin neck, ring base, and a handle in their original form and thinness. Upon a careful observation on some Urartian vessels, traces of implements under the slip can be seen. On some occasions, the traces were smoothed by wiping by hand. Therefore, it may be assumed that the potters in Urartu reached the final form of the vessel in several stages. After preparing the paste, it is shaped on the bench as thin and as close to the original form as possible. It should be left to rest for a while and allowed to dry partially. After this process, it is scraped using various tools. The scraped body is shaped to be round and the base is shaped as a ring. Its body thickness is reduced and the vessel becomes lighter. Slip experiments. In general, slips are made by filtering and settling the soil used in production. We choose red clay to make slip for its color, so it would be the self-slip for red clay. For the experiment, we prepared 5 cm by 5 cm test pieces in a plaster mold so that we could try various slip types on them at the same time. Both green and red paste were used. We dried them till they become leather hard and they were ready for the slip. We categorized the test pieces by clay, slip variations, you can see here. 1A green clay, 1B red clay. This is slip variations, simmered, not simmered, and according to the location in the kiln, etc. And we categorize the test pieces by clay type, a slip variation, and when placing in the kiln, we marked them on their back. Self-slip red paste was called 1B and the green paste 1A. Each has subgroups on the basis of slip variations and firing. There are several steps in preparing slip and several variations. I will explain all these very briefly. These are mixing the material, siphoning the slip layer, simmering, and applying. Simmering may not be necessary. For mixing, slips are prepared by using the settling separation method and deflocculants. Deflocculants are basically water softeners. We use local red clay, rainwater, and sodium silicate as a deflocculant. which enables the suspension of the very fine particles in the slip. We mix them thoroughly and put them in a glass jar. We left the jar on a desk undisturbed for 46 to 72 hours. During the sedimentation process, very fine clay particles are dispersed in the water. When the heavy particles precipitate, the finer ones above the sludge are siphoned off into another container. In one case, we simmered the slip, since this is one of the steps in the making slip. Simmering is generally used to eliminate burnishing. Finally, we applied slip to the test pieces 2 or 3 times when they were leather hard with rugs and sheep wool. Some of the test pieces were polished with an agate stone and metal tools. After drying in the workshop for 3 days or 1 night on the roof together with Osman's other pots, the test pieces were ready for firing. The kiln. We don't have any archaeological evidence as to whether Urartians performed firing in an open heart or inside a kiln. Yet we, when considered the Urartian wares have non-porous, smooth and vivid red surface, fairly developed firing technologies must have been used rather than simple pit hearts. 4 types of firing methods and kilns are known to have been used in various places in Anatolia. The nature of the red Polish pottery and the traditional kilns in Bardakçı may indicate that the Urartians used a kind of mud brick kiln, you can see in the slide. Now, I would like to give a general information on the kiln at Bardakçı. It has 3-meter base diameter, a round form, and a 1.35 meter diameter flue. First, a hole is dug in the floor to construct the kiln. The hole is for the fire. After stacking up 13 lines of mud brick, inputs are stacked up. The kiln narrows towards its top and is 4 meters tall. The inside of the kiln can be likened to an inverted storage jar. The kiln has 2 doors. The door on the underside is the fire door, and it is used to put fuel for the fire in the kiln. The door in the upper side is used to place the ceramics. The ceramics are placed onto a perforated platform so that the fire can properly reach to the upper side. This sort of grate-like section allows for a good and even firing by providing regular air circulation and heat to the upper story where the pottery has been placed. However, some vessels are also placed on the platform in the fireplace. One can reach the upper door by using several access steps located right next to the kiln. Yeah. The steps on the exterior of the kiln that means that steps. I mean, now I'm talking about. Exterior of the kiln indicate the thickness of the kiln's wall. If the kiln is not surrounded with a wall of this thickness, it will crack and the interior slope cannot be formed. It is designated as a dome, narrowing towards to top to prevent heat loss and bake the vessels equally. A kiln of this size needs to be built on 3 arches. The part until the curve of the arch is the first step in the kiln seen from outside. The arches are resistant up to 1200 Celsius degree, but may be damaged at higher temperatures. A kiln of this size can hold approximately 300 vessels of varying sizes. This type of kiln is the earliest type of kiln used in the village of Bardakçı and is regarded as a monument. Yeah, putting the pottery in the kiln and firing. The ideal seasons for baking the ceramic are the months without rain, but also not too hot. Therefore, the ideal period for baking is in the spring months. This is also important for collecting dry fuel. The vessels should be dried slowly in a closed area about for a week. They also should be left to rest to eliminate humidity. The dried vessels should be taken out at sunset or before sunrise to protect them from direct sunlight. They are left outside to rest for 2 or even 3 days. The ideal time to put them in the kiln is midday. The vessels should heat and be free of humidity. The fire holes should be left empty while putting them in the kiln. Therefore, the placement of the first, that means bottom, row is of great importance. Good placement is a factor that directly affects the quality of the firing. The risk of cracking is high for small kilns since the temperature rises quickly. Losses will be reduced in large kilns since the temperature rises slowly. Rising temperature is the most important factor in firing vessels. Weeds, straws and thorns should be burnt so as not to overheat in the first hour. After 1 hour, wood can be used and burned for a maximum of 2 hours. High calorie wood should be chosen and the temperature should rise slowly. Relatively large storage jars that can contain 30-35 liters of liquid are placed on the bottom row, so their base will be on the floor since the heavy load of the other vessels will be on the top of them. This weight may be reached a maximum of approximately 7 tons. If the storage jars are not placed straight, the load will break them. However, the storage jars can be slanted in relatively narrow kilns like ours. The risk of breakage is low because the loads will be less. The vessels are placed into the kiln in order of size from large to small, since the bigger vessels needs to be exposed to higher temperatures due to their thicker bases and walls. Many plants and trees are provided for the fire from the immediate vicinity. Unfortunately, I couldn't find the English equivalents of some of the plants that I list. The plants used as a fuel include oak, locust, rose, hawthorn, pine, fir, hocabaşı dikeni, kind of thorn, çatakuş otu, henbane, teasel, willow, silverberry, yellow sweet clover, reed, goat's thorn, potherium, hog fuel, and wheat straw. We distributed the test pieces prepared for our experimental study and applied slip to the different areas of the ceramic alcove at the upper side of the kiln. We placed the storage jars with relatively thicker bodies on the fireplace at the bottom and the jugs on them. Placing the larger vessels such as storage jars, big jugs, etc. in the kiln's ceramic alcove without covering the fire holes is important for flames and air to easily move towards the top. We placed the thinner and smaller vessels at the top and covered them with broken pieces to prevent the baked vessels from cracking due to the wind. The upper door was laid up with mud brick and plaster to prevent air from entering the kiln. We placed a thermocouple on this door to measure the temperature of the kiln. Baking continued for approximately 5 hours. The temperature kept rising. The thermocouple showed the maximum temperature in the kilns as 1050 Celsius degree. The fire door of the kiln was immediately closed, laid up with mud brick, and plastered without letting the temperature of the kiln fall abruptly when the process of increasing the temperature ended. Cold air and oxygen entering the kiln at this stage would cause the vessels to crack. The temperature of the kiln reduced until the next day, and the ceramics were taken out the next day. Results. We took out and evaluated our test pieces after baking. First, I must say that none of them were the desired red color. The color we desired was supposed to be 10R for 6 or 10R for 8 according to Mansell soil color chart. Our closest results were 5YR and 2.5YR, 5.8 and 6.8 in the test pieces produced from red soil with self-slip. The samples that we polished were relatively brighter, but still not at the desired brightness. We concluded that there were several different reasons for this failure. The failure in the desired color might be due to the fact that the clay used for the slip did not contain the correct elements. This led us to reach for a new source for slip. 1000 degree may be too high for red clay with red slip. This temperature should be reduced around 700 or even to 600 Celsius degree. And some, of course, mistakes may have been prevented us from obtaining the desired color. New methods should be tried. However, our experiments enabled us to understand the fine details of processes. These are our observations based on our results. The ceramic from local clay and slip clay loses its red color at very high temperatures. The placement of this type of ceramic, type first quality, into the kiln affects the quality of baking and color. The vessels placed close or far away from the fire seem not reach the desired color, and this may be the reason for finding different colored ceramics in the excavations. It seems that 10-15 pieces can have the qualities of palace ceramic in a kiln out of 150-200 pieces on average. The fact that the kiln was lit in the evening in darkness may be the reason, since the vessels should be observed as they turn into the ideal red color, and the fire should be extinguished accordingly. This may also provide information on the temperature of the kiln. The kiln and ceramic workshop would not have been in fortress because, firstly, the smoke is intense. Secondly, carrying fuel up to the fortress would have been difficult. And thirdly, a large area is needed for ceramic production. When some samples of the highest quality BIAA ceramic with red slip are examined in detail, it can be claimed that in reality may not have been polished. If they were not polished, some other methods must have been used to obtain the shiny and sintered exterior surface. Some sources suggest that use of basalt to make slip, a volcanic stone frequently encountered in the region, was one of the factors that caused the brightness, but it's impossible to prove this without further testing. On the other hand, the baking method should be considered since it may be a factor in the pottery's brightness. This reminds us of the red examples of Roman terra sigillata. Terra sigillata was produced and traded throughout the Roman Empire, beginning in the 1st century BCE, and sealed with figures specific to the workshop of its production. This ceramic type has sintered paste like Urartian ware, and its slip is made of very thin clay. Again, these types of slips are prepared through settling and separation method. The iron oxide in the slip turns into red due to the oxidation in the firing environment. Thus, there might be a technological analogy between Urartian red ceramic and terra sigillata. If the correct material is used for slip, red and bright Urartu ceramics can be produced using similar methods. Future works. We obtained some interesting data while studying the literature in the summer of 2015. We learned from a book on primitive pottery in Turkey that ceramics were produced with traditional methods and sold in some villages of Bitlis in the 1970s. And the ceramics were red due to the use of a red and very thin clay slurry called avusku. According to the book, the vessels were baked twice in these villages. The vessels were internally and externally slipped with avusku and rebaked after the first baking. The ceramics are red and slightly bright after the second baking. Bitlis is in the Van Lake Basin and lies within the Urartu territory. There are very important and fairly large fortresses in Bitlis, such as Adil Cevaz Kef Fortress, which was a cultic center. We think that the bright red ceramic tradition in the villages of Bitlis may provide important data for our studies. Thus, we decided to go to these villages to find this thin red soil and use it in our analysis and practices. And more importantly, to obtain information on the production methods used in these villages. On the other hand, the research that provided this information was conducted almost 45 years ago. Moreover, in the summer of 2015, going to these villages was risky due to the terrorism in the region. We set off towards morning after informing security forces and obtaining their advice. We had to return from Bitlis before sunset for security reasons. When we reached the village of Günkırı, we found that the village had become a district and that its people had stopped making ceramic long ago. But the women maintained the tradition of making tanders. We tried to find the red soil in the mountains near the village for hours, but were unable to find the type of soil with characteristics described. We had limited time and lost our energy and hope. We realized that our efforts were unnecessary when we returned to Günkırı village, because this red soil type was sold for only 10 liras a tin. We bought the necessary amount of soil for our analysis and practice. We plan to have the soil analyzed and do our comparison next year. I hope to continue our efforts with the red soil we brought from Bitlis and share our results with you once again. Thank you very much.
Thank you very much. Thank you very much. I think it was extremely interesting. I hope that you will have enough hope and energy left to continue and finish this project. And I'm sure that that there will be many people with questions today. So, Orly, I can see you.
I don't even know where to start. This is really exciting. I think you're on the right lines thinking about the terra sigillata connection. I have a background in pottery making, and I've done a little bit of experimentation a long time ago. And yes, you're looking for something like an iron saturate clay to make your slip from. And also you might want to think about adding an extra little bit of flux. There's some textual evidence to suggest that a soda ash made from burnt plants was actually used to help improve the brightness as well. So you might want to think about that.
Well, great. I really need that kind of guidance and criticism and opinions. What kind of ash you're talking about? I mean, is there any specific type of plant?
There are a few different types. You need a plant that's got a high silicate content, so that when it burns it produces, and also things with lots of sodium. So for instance, in Britain we have a plant, I'm sure that it's not grown here, but you'll have something similar with glassport, which actually used to be used to produce soda ash for the glass making industry and the pottery industry. You can buy this material also from pottery stores and things. But I was recently, actually just yesterday, at a conference in Istanbul, and there was a lady talking about the production of frit in eastern Anatolia, and also in the southwest and in Syria. And she was mentioning a plant that grows all over Turkey that was burned to produce a soda ash. And I will find her email address and get you two in touch, because she might be able to help.
I really appreciate that, because we need that at the moment. Okay, thank you.
Are you carrying out any petrographic analysis or any other pottery analysis that would complement the work you're doing?
Yeah, we have a couple of analysis type XRD and some petrographic analysis as well. I can also show you in the slide the compounds of the clay that we use and the original clay. Yeah, we have the color codes, the original one, and we have XRD analysis, and but we have a ceramic engineer. I don't know that kind of chemical kind of stuff, but he is just taking care of the chemical analysis and etc. But we have been doing some analysis, yes.
Thank you very much for the talk. I mean, it was really amazing, but I cannot give you any kind of technical criticism because it's not my field. But I wanted to ask you a very simple question. What's going to happen if you find what you're looking for? So, if you find the Urartian pottery, and then does the project benefit?
I'm just, first, of course, we need to write down something and publish something. It should be bilingual, English and Turkish as well. It's gonna be a book, I suppose. And afterwards, we probably teach the people that want to know how they produce the traditional and Urartian pottery, and disseminate all this tradition. Firstly, in the region, think that Avanos, for example. Avanos is a nice example to build a new project to disseminate the people and for the tourists as well.
Yeah. Mm-hmm. Because in Van now there's a growing. I mean, there is already an industry.
Yeah. Yeah. This is just ongoing project, and we are just at the beginning stage. So we have a lot of way to go. So we have to wait first.
So you
just focusing on the reach the desired color first.
Okay.
Yeah.
I would also like to ask something. I'm also not a ceramic specialist at all, but if you listen to the sound of the fragments of ceramic that we have, they sound very hard. So, and I always thought that these kind of sintered hard surfaces were obtained by very high temperatures.
Yeah.
But that's obviously not the case then, because 600, 700 degrees is not
I know.
that high, is it? Or
Yeah, we tried it for the local paste, 1000 degree, but it became melted but we need to try more practice. I know I read some articles about the artistic features of the ceramic. I know if you reach the very permeable and sintered ceramic, then the temperature at least must be 900, 1000 and more. But in this case, in this particular case, the local clays doesn't allow to do that for us.
Yeah.
So we tried it, we couldn't reach any result with this.
Okay. There goes the specialist.
No, I was just thinking that what you might want to try to do if you're interested in working out exact firing temperature is sacrifice a few sherds to a refiring process in a lab to see at which point your breaks start to remelt, and that will give you like your upper reach of the temperature that you're looking at.
Yeah.
Because it's all about control of the silica mostly.
Mostly.
With regards to this.
Yeah, yeah, it's very difficult because we have a huge kiln. Unless you put load it, you cannot fire it. And there is no any small laboratory in your room. You have to do in that place. So this is another difficulties for us.
Energy and hope and time.
Yes.
Yes.
First of all, thank you very much for this very interesting talk. I have a very simple question. How long the paste preparation takes?
Yeah, it takes half days, but it depends. If you need to take the clay from the deposit, it takes a couple of days. But when you begin in the workshop, it takes about half day. Yeah.
Okay, I was just curious about the boy. How
Yeah,
long
yeah.
he has to work.
Very helpful, very helpful. He did everything, mudding and as a Shagit's work, and yeah, he is very nice guy. Oğuzhan is Osman's son and also Shagit as well.
He's lucky.
Yeah, but yeah.
If there are no more questions here, then I suggest that we are all going to continue discussing this topic with a glass of some börek.
Oh.
Thank you very much for
Thank you.
this interesting lecture, and we'll see.
We'll see next time.
We'll see, and see you again.
Thank you.